We're going to shift over and we're going to prove angles congruent. Okay, starting out with one that should look similar to one we did in 2.7, right?
Looks like a fork.
Looks like a fork. Okay, so what do we have? Basically, if you have two angles that are adjacent to each other, so when it says this whole thing here, this is basically saying that we have adjacent angles. What are adjacent angles? Two angles that have a common vertex, common side, but share no common interior points, right? So they're not overlapping. It's this distinct angle and this one. So if we add this angle plus this one, we get the whole thing, right? Not, again, it's a postulate because it's kind of obvious. If I told you that this was 30 degrees and I told you this was 40 degrees, what would the whole thing be? 70 degrees, right? We just accept that, right? Okay, we got a 2-column proof. Fortunately, all the statements are there for us. Now, if you have that paper.
One's given.
What's that, Evan? I just threw in some examples, right? If you have a 30-degree angle and a 40-degree angle, it's going to add up to 70 degrees. Okay. Good? Okay. This worksheet that has all the theorems and definitions for chapter 2, it's good to have that handy for this lesson. Okay. Measure of angle 1 equals measure of angle 2. I give you a point on quizzes and tests, even for the given. So always put that one in. Also, what's always the last step going to be? It's always what you're trying to prove. Now, we don't necessarily know how many steps are in between, but always write out this and make sure that last statement is always your proof. Okay? All right, let's label. Angle 1 and angle 2 are congruent.
Yes.
Are equal. So we mark that. Okay, what are we trying to prove? PXR, so I'm just going to kind of trace. So here's PXR, and I want to make that congruent to SXQ. Will those be equal to each other? Yeah. How do we know? Well, the green one is a combination of angles 1 and 3, and the purple one is a combination of angles 2 and 3. And if 1 and 2 are equal, then it makes sense that the big angles have to be equal. But we got this 5-step proof that we want to just fill in all the details. Okay. This is usually, if you are writing your own proof, this is an optional step. I just wanted to throw that in there.
Is it reflex?
That's reflexive property. You can abbreviate. You don't have to put property, you can just REF, that's fine. Okay, now measure of angle PXR, so we're looking here, equals measure of angle 1 plus measure of angle 3. And then SXQ is measure of angle 2 plus measure of angle 3. What's that? Angle addition postulate. That's what angle. I think you had missed that when you were out.
Oh.
That was like the first thing that we did. Okay, angle addition postulate. The only difference is we're talking angles instead of segments.
Oh.
Okay. All right, what is different, or what do we need to fill in here? So let's see. So nothing happened with the first line, that just stayed the same.
Measure of angle 2. Substitution.
Okay, but what do I want to replace angle
Measure
2
of
with?
angle 1.
Measure of angle 1.
Yeah. I said yeah.
Substitution. All right, we just replaced one thing for its equivalent. What allowed us to say this is angle 1 here? Because angle 1 is equal to angle 2, so I was able to replace that. Now, what do we notice here? Measure of angle 1 plus measure of angle 3, measure of angle 1 plus measure of angle 3, therefore, these two are equal. You could do transitive or substitution, okay? Either one of those would be fine.
So technically, you could have done 4 and 5 in one step. Technically.
Yeah. Okay. What do you think? So all those statements were there, but we had to come up with the reasons. That was all right?
Easy when you like show us. But then you
I know, when you have to do it on your own. I get it. I get it. Okay, let's do some applications of segment, or sorry, not segment, angle addition. So not proofs. Applications, meaning we're just solving for an angle measure. Okay, what do we know? We know measure of angle 1 is 23, and ABC, so ABC is the whole thing here, is 131 degrees. What's the measure of angle 3? How do
You do 131 minus 23 minus 90. Oh.
Okay, so we can see measure of angle 1 plus measure of angle 2 plus measure of angle 3. That whole thing is 131 degrees, right? And if angle 1 is 23 and angle 2 is 90, yeah, it's fine. What you said was correct, right? We're going to end up taking 131 and we're going to subtract 90 from it. We're going to subtract 23. And what's that give
know how to
us?
do subtraction.
You forgot how to subtract? Come on, we can subtract. 23 and 90 adds up to 113. So really it's 31 minus 13, which is 18. We can subtract. Did you have to do some math without a calculator yesterday? Yeah.
I actually forgot how to.
You forgot to bring one? They had ones that you could have signed out.
They said they
In
had
the-
none.
Oh, did they run out?
Yeah, they were like, if you forgot your calculator, it's malfunctioning, we can't do anything.
Oh. They had some in the office, but oh well. Okay. Where did I get what? 90. Angle. It's a right angle.
Marjorie, 131 degrees.
ABC is 131. That's in the directions.
Oh.
You see it? Okay. Angle 6 and angle 7 form a linear pair. That means angle 6 and angle 7 add up to 180. Okay, we know measure of angle 3 is x plus 20. Angle 4 is x plus 40. Angle 5 is x plus 30. 6 is 3y plus 32, and 5y plus
So much
12.
going on.
There's a lot going on. There's a lot going on. Okay, well, we could add all those angles up and say they're 360, but we're gonna have x and y in the same equation. So we wanna do two different equations, right? One involving x and one
So
involving,
the x equals 180 and the y equals 180?
yeah, so all three of these, 3, 4, and 5, also have to add up to 180, right? If these two add up to 180, then these three also have to add up to 180. So we're gonna
You
have,
could do the whole thing equals 360, but then you have to like,
then you'd have x and y in the same equation.
yeah, but then if you solve for one of them, it would still work, right? It would just take a
It
lot
would.
of time.
Well, how would you solve it with just one equation, though? Did you have some on the PSAT where you had to do elimination or substitution? Remember those?
Yes,
Yeah.
and it was like, and I forgot how to do it. It was like 2x something plus, and then you
Yeah.
have to like x out both of them.
So
and
if
find
you
out.
were, but if you were to add all 5 of those angles and make it equal to 360, you only have one equation and you have 2 variables. So you'd need something, you'd need some other information. So that's why that's easier if we just add them up this way. All right, the x, let's see, what do we have? 3x. And then 60, so 60, 90, so that means that'll be equal to 90.
So
X equals 30. And then for the y's, what do we get? 8y plus 44. Okay. 136. And what do we get for y? Does it go in?
Probably does. But
How do we?
I can't find my calculator. Oh, my calculator here was dead.
17.
That's not very convenient. 17?
17.
Okay.
You don't use-
All right, and then we want to just go back, measure of angle 3. That's easy. The x's are easy, right? Angle 3 has to be 50. Angle 4 has to be 70. Angle 5,
60.
60. Also, all 3 of these angles must add up to 180. So you can do a quick check. Yes, that adds up to 180. And how about the other one? So 5y plus 12 for angle 7 and 3y plus 32.
5 times 17. 85.
What'd you get?
It's 5 times 17, 85.
Yeah.
Plus 12.
97 for angle 7. And 3 times 17, so that's 51. 51 plus 32. 83. Do 83 and 97 add up to 180?
Yeah.
Yep.
Yeah.
Okay.
No way you lose those blocks.
All right, we have supplement theorem. We've actually done this before, just kind of going over it again. If you have 2 angles that form a linear pair, then they are supplementary angles. That should be on your paper. You see supplement theorem. So again, I'm going to give you this paper. I'm going to give you so if you want to write on this, it's fine. I'm going to give you a clean one on the day of the test. It will say supplement theorem close to the middle. I'm not going to tell you what supplement theorem is. So you need to know what supplement theorem is in order to apply it. So what does the supplement theorem say?
2 angles
Form a linear pair?
They're supplementary.
They're supplementary. So you can say that they're supplementary. What's the complement theorem?
November 7th.
The 24th.
Oh. Of October?
Yes.
Oh. That's kind of close.
Okay, that's like 11 days, and we're on the last section. So
Well, actually, still have time to review.
yeah,
Oh.
yeah, see?
Nice.
We're finishing the chapter today.
Oh.
Okay?
Fantastic.
Next Wednesday, we're going to spend time reviewing the proofs.
Oh, facts.
So
Thursday's going to be our review day, and then the following Monday will be the test.
it's actually like 3.
Okay, so we have time here. Okay. Yeah, Evan. What?
Oh, that's plenty of time.
What's that, Evan?
I have flash, like, can I have like enough flashcards to write down all the
I mean, I don't supply flashcards, but that's something.
Where do the kids get from?
You don't supply flash.
Yeah.
Miss H has
So
flashcards. I'm sure she'll love to.
I supply my own children with flashcards, but not because it's something. It's like supplies for class.
Ooh,
like
what if Owen gets them from you to give to us?
Oh, that's tricky. Okay. You might beat the system then. All right. 2 adjacent angles form a right angle. Then the angles are complementary. Okay.
Of course.
Shh. So complement theorem. You have 2 adjacent angles form a right angle. Then they're complementary. So we have our supplement theorem, linear pair, supplementary.
Supplementary is just doubles. Supplementary is just double.
Yeah, but we wouldn't say double complementary, right?
Supple is double couple.
That's how I think.
Simple is.
Okay.
Yes.
Yeah, it would be wrong. Okay. Properties of angle congruence, just real quickly, these are the same. We've done them, reflexive, symmetric, transitive, just get used to them.
So it's just the same thing as the other one?
My
or
statement-
It's just with angles.
Sine instead of a.
It's just with angles, that's all. You're gonna use them exactly the same as you would for the segments, okay?
So when do you use the one for the segments? When do you use the? Oh, you use this one for angles.
You use this one for angles. Okay, this is a new one.
My staple came out of one.
Sorry.
No way, congruent supplement here.
Is that necessary?
Okay. Congruent supplement theorem. Okay? If you have angles that are supplementary to the same angle or congruent angles, they will be congruent. Okay, so the wording is a little confusing here. Look at the example I have here. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. So that's going to tell us we have a pair of congruent angles.
But isn't it also like vertical angles?
Well, they're not yes, if they were connected, it would also work the same
Oh,
way.
it implies that angle 1 and angle 3 are congruent.
That's literally what it says.
Yeah, I know.
Okay.
So angle 1 and 3 are.
So if you have two different angles, angle 1 and angle 3, that are supplementary to the same angle, angle 2, they have to be congruent to each other. So for example, let's say angle 1 was 130 degrees. So if I said angle 1 and angle 2 are supplementary, and just as an example, this is 130, what would angle 2 have to be? 50. And then in a separate statement, I said 2 and 3 are supplementary. So if angle 2 is 50, 130. So these, no matter how I choose the angle measures, they're going to end up being the
It's
same.
really easy when you explain it like that.
So that's why I like to put them, because we don't always have numbers in geometry, right? When it comes down to the proofs, it's all letters, right? And but when you look at it in terms of the numbers, it makes sense.
Would you say that algebra 2 is harder than geometry?
Yes.
Did you say algebra 1's harder than geometry?
Okay, on to this. Shh, you can ask me random questions later. Congruent complements theorem. It's the same thing, but with the complementary angles, right? Angles complementary to the same angle. So if angle 4 and 5 are complementary, so let's put some sample numbers. So let's say this was 20 degrees. So if 4 and 5 are complementary, 5 would have to be 70. And then if I said 5 and 6 are complementary, if 5 is 70, 6 is going to end up being 20. Again, no matter how we choose those numbers, 4 and 6 are always going to be congruent. Okay, we're going to prove this last theorem. We're going to prove the congruent complements theorem, which, how does it start off? It starts off with two pairs of complementary angles. Now, I can't use the theorem in order to prove the theorem, but I can use any other theorems or definitions on that paper.
It's like a bunch of congruent stuff.
Okay, so let's 1 and 3 are complementary.
You write comp.
Yeah. And then we have 2, not 180, but what's complementary?
It's just substitution.
Complementary.
Okay, hold on, Evan.
Oh, nice.
Slow down. Let's like write down the given.
Oh yeah.
You were on the right track. Yeah, I knew you just said the.
Wait, can
Okay, just yes, yes. Now you're raising hand, and now go ahead. What were you gonna say?
I was gonna say I confused complementary with
Okay. Do you have something other than the complement theorem on that paper? Do you see anything that says something about complementary angles?
Yeah.
Definition of complementary.
Definition of complementary angles. What does the definition of complementary angles say? It says,
Angles add up to.
okay, so I'm going to put a little m in front of angle 1. Okay, it says the measures of the two angles are equal to 90. So then I'm going to put a plus sign, right? Measure of angle 3 equals 90 degrees. I will tell you, you don't need to, I will tell you, anytime you put a little m in front, you technically don't need to put a degree sign because it's implied that you're talking about degrees because you're talking about the measure of the angle. If you put a little degree sign in there, it's fine. Okay, so we just said, what was the reason? Definition of complementary angles, and we can definitely abbreviate. Again, for angles, I just do a little angle symbol with an S. Now, can I put something else in that same statement? What are the other two angles?
Wait, what is angle as angle 3?
So substitution.
Measure of angle 2 plus measure of angle 3 equals 90. Now remember, what am I trying to prove? I'm trying to get angle 1 and angle 2 congruent.
Right.
Okay.
So could
Anybody have an idea what might be the next
If they
statement?
both equal 90, then they both equal each other.
Okay, what both equal each other?
Three on
Measure
both
of angle
sides.
1.
Plus measure of angle 3 has to equal. Good. They're both equal to 90, so I can set measure of angle 1 plus measure of angle, I should have given you guys a little more space for this. Angle 3 equals measure of angle 2 plus measure of angle 3. Okay, that could be substitution. I would also accept transitive. Okay, and I think again, what are we trying to prove?
Measure of angle 1.
Is-
Measure of angle 1 equals measure of angle 2. Well, it's congruent to, but the next step is.
So we have to do
I thought you have
equals.
to make it congruent as the last.
Good, so measure of angle 1 equals measure of angle 2. What did we technically do to get to subtraction? Good. You guys are getting better at these.
More sense now.
And now
They're congruent.
they're congruent. Angle 1 congruent to angle 2. Definition.
Equal 0.
Definition of.
Congruent.
Okay. Okay, how was that? Like I said, the more practice we get with these, they do get better. I'm not going to say they're not always super easy, but
Leave it up for a second and just finish it.
yeah. Okay, now we're going to prove the vertical angles theorem. That was one we also learned previously. What is vertical angles theorem? Does anybody know? Alec?
The vertical angles in their congruent.
Congruent, that's it. Vertical angles are congruent.
That's
That's
you try to
that's
trick us with our congruent angle is always vertical.
Oh my god, that's so.
That's just not true.
vertical angles are always congruent,
Congruent
Yeah.
but congruent angles are not always
Yeah.
right vertical. Are we good?
Wasn't that a question? Of like,
It could have
maybe it
been.
was the review or something.
Yeah, I was giving you a lot of those. I think we need to practice some more of them.
Always, sometimes, or never.
I
Yeah.
went over them with my math.
Just get rid of those.
We're good.
Okay, what do we have here?
Definition of, or on the one before was the definition of complementary angle, definition of,
Congruent angle.
Congruent angles.
but then before was.
Before,
It was.
well, we used complementary angles when we said the measures added up to 90. But then whenever you're switching from equals to congruent or congruent to equals, we use that definition of congruent angles or
I do
segments.
LP.
Sure, I know there's not a lot of space here. Linear pair, I'll kind of abbreviate here. Angle 2 and angle 3 form a linear pair.
So
And
we do the congruent thing and then do definition.
okay, it has to be something on that piece of paper that has to do with a linear pair. It's one that I put in this section. We go back. Was there anything that had to do with a linear pair?
Supplementary.
Oh, right here.
Supplementary.
Supplement theorem.
Oh.
What were we given? We were given that we had
Supplementary.
2 linear pairs. So if they form a linear pair, what can I say about the pairs of angles?
Supplementary.
They're supplementary, okay?
You do like angle 1 plus angle 2 equals.
Well, that's jumping right to definition of supplementary angles. What was the supplement theorem? It says angle 1
Supplementary.
and angle 2 are supplementary. That is the supplement theorem.
And we do like the other one, right?
Alec, you had a question?
Oh, I just did.
Okay, so if all you know is that they're a linear pair, all we can say about that at this point is that they're supplementary. Now, in the next step, if you want to do measure of angle 1 plus measure of angle 2 equals 180, that's definition of supplementary angles. I know. It's like, again, it's that kind of obvious step in the middle that we can't skip. So I am going to write it out in words. Angle 2 and angle 3 are supplementary. Now, I could make this this could be a 3-step proof.
Instead of supplementary.
It could be a 6 or 7-step proof.
Or instead of supplementary.
Can I make it a
you're
4-step
gonna
proof?
sup, like SPE.
How do you like
Sure.
So I wanna do that.
I can actually prove it right now. I just need to pick the right definition or theorem. Did we have something about 2 angles that are supplementary to the same angle?
Oh, is it with the
We just did it. Okay. Did I have angles that were supplementary to the same angle? What can I say about those angles? They're congruent, right? Look at this example. I had angle 1 and angle 2 are supplementary, angle 2 and 3 are supplementary, so I was able to jump right to angle 1 congruent to angle 3. Now, let's say you didn't recognize that that was a thing. What would your other approach be? To do measure of angle 1 plus measure of angle 2 equals 180, measure of angle 2 plus measure of angle 3 equals 180, then you would make them equal to each other,
Well, that's what we
you
did
would
the last
subtract.
time, basically,
Right. Here's the whole point with proofs. If you know the theorems really well, you can make a really short proof, right? So I recognize I don't need to do all those extra steps. I can just jump right to angle 1 congruent to angle 3, and this is the congruence.
Wait, so they're postulates, theorems, and
Definition, postulates, and theorems. There's something later on we'll have called a corollary, but we don't need to worry about that.
Yo, what?
So don't worry about it. I said don't worry about it. Right now, just definitions, postulates, and theorems.
Only.
See?
This is what-
So if you know the congruent if you were able to recognize that, you would only have a 3-step proof. If you didn't,
The other
it
ones
would have to
down.
be another 3 or 4 steps.
Would that be fine though?
Yeah, that would be fine. So that's where
It's
if
just more work,
it's just more work. So that's why I encourage you to do flashcards.
which you won't give up.
wait, I wasn't.
I won't provide you.
Just roll up me. I'm so sorry.
Okay, right angles. We've already done a little bit of right angles. Definition of perpendicular lines that intersect to form right angles. There is a theorem. It doesn't have a name. It just says all right angles are congruent. That makes sense, right? All right angles are congruent?
So it's the all right angles are congruent.
They're not.
Yeah, you just write out, you literally, like, all right angles are congruent. That's the theorem. You see the very last one on the paper? Oh, if you have your paper? I see some of us have. What's the very last theorem say? All right angles are congruent.
So that's what you put in the reason?
That's what you put in the reason.
What is that weird? Like,
Oh,
it's
you
just.
abbreviate
what?
right in.
Oh my god, I saw that on
What are you
one of
writing?
our things.
What's that?
All right.
You just write it out.
Like ARAAC.
Yeah. Okay,
Abbreviate that by saying like writing ARAAC.
okay, you can abbreviate so much, but let's,
What is that?
that is perpendicular.
So don't they all have to be right?
Okay, so what's the definition of perpendicular lines? All of these are right angles. Okay, now what am I trying to prove?
That, but
AEC is congruent to BEC. Okay, so I could list all 4 of these angles are right angles. But-
can you
I really just need to state these 2.
The linear
supplementary theorem?
Okay, wait a minute. What did we just say? What do perpendicular lines tell us?
All right angles are angles.
Okay, hold on. But definition of perpendicular line says lines that intersect to form right angles. That is all I can say at this point. I can only say angle AEC and angle BEC are right angles. Try not to skip too many steps. I know it seems, again, like an obvious thing, because you know they're going to be congruent, but we have to say that they're right angles. Why? Definition of perpendicular lines, and we can abbreviate for perpendicular. Okay. If they're both right angles,
All right angles are.
all right angles are congruent. So now I can say angle AEC. Bless you. Now, another approach, I could have had a longer proof. I could have said measure of angle AEC equals 90, measure of angle BEC equals 90. Definition of right angles, then I can make them equal to each other. Then I could say they're congruent. But it's much easier to just use all right angles are congruent. And it has a 3-step proof instead of a 6 or 7. Ariel? Well, is anything